Hi, sixth graders. We're moving on to our next unit today. So if you'll remember from last unit and the things that you just took a test on, you took a test on adding integers, so negative and positive numbers that we add together, subtracting integers, which remember we change into addition problems, and then multiplying and dividing integers. So that was all in the last unit, and today we're going to use all of that information to work into our next topic, which is called order of operations. Order of operations. And you have had some previous work on order of operations probably in 4th and 5th grade. And we're going to review some of that, and we're also going to look at what this means for integer operations as well, so throwing in some negative and positive numbers. So order of operations, its definition, what does it mean when we talk about the order of operations? Well, if you think about operations in general, when we refer to this word, operations, we're talking about things like adding, subtracting, multiplying, and dividing, right? An operation is just a math problem. You're taking two numbers and you're adding them together. You're taking two numbers and you're dividing them. Those are operations. And so when we're talking about the order of operations, we're talking about the order in which we perform these, especially when we have more than one. So the definition is when a math problem has more than one operation. And again, when we're talking about more than one operation, we're talking about adding, subtracting, multiplying, dividing. We're actually also talking about exponents, which we've already done. Remember those little numbers that fly up in the air? We're going to involve exponents in this as well. So I guess we should have added that up here. But when a math problem has more than one operation, the order in which we calculate answers matters. The order in which we calculate answers matters. So let me just show you a quick example. I'm going to tell you a quick little story. So I'm going to split my page down the middle for about 4 lines. And let's pretend we have two people. Let's pretend that we have Emily and we have Tracy. All right. And let's pretend that they're working out a math problem. And let's say that Emily does the problem like this. Let's say that the problem is 2 minus 3 times 7 plus 9. All right, so let's say that they're working out this problem. So Tracy's going to work out the same problem. 2 minus 3 times 7 plus 9. All right, and let's say that Emily starts doing this. So let's say Emily says, okay, I'm going to work out this problem. So I know that 2 take away 3 is negative 1. 2 take away 3 is negative 1. And then I'm going to bring down the things that I haven't done yet. So she worked out this problem. And let's say then she says, okay, well then I know that negative 1 times 7 is negative 7 plus 9. And then I know that when I add a negative and a positive number together, I actually subtract them. This is from last unit. So 9 minus 7 is 2. And there's more positives here, so my final answer is 2. And so she gets her answer as 2, working out the same problem. Well, then let's say that Tracy's working out the same problem, but let's say she looks at this problem and she says, okay, well, I know that my multiplication facts, so I know already that 3 times 7 is 21. And so then I need to subtract that from 2, and I need to add 9. And then let's say she knows, okay, well, 2 minus 21, that's hard to do because that's going to end up negative. So I'm just going to go ahead and add these numbers together. And so 21 plus 9 actually gives me 30, which is a nice and even number. So that's good. And I still have this 2 minus out here in front. And then, okay, now I actually I'm forced to do this hard subtraction problem, so I know that all subtraction problems turn into addition problems by keeping the first and switching to addition and flipping the last number to its opposite sign. So I, correctly change the subtraction problem into addition. And then I'm left with the same issue over here. I've got two numbers of opposite signs, so I'm going to subtract them. 30 minus 2 gives me 28, and I actually have more negatives here, so my answer is negative 28. And so Emily comes to her teacher and says the answer is 2, and Tracy comes to her teacher and says, hey, the answer is negative 28. And their teacher is like, well, you started with the same problem, so there's no way you can both be right. And actually, it's like you did the problem in different order, right? Like that's why you got different answers. So Emily started at the beginning and worked her way over. Tracy started with the multiplication and then worked her way around the problem, and they ended up with two different answers. Now, they both can't be right. They actually could both be wrong. But this is why it's important that we have order of operations, because when we work out the same problem, we should get the same result. And so what happened was that, this situation arose so much that someone decided, hey, we need to make sure that everybody is doing the same order, is working problems out in the same order, so that we are getting the same answer and that we can express math problems in a way which we are going to get the same answer, okay? So that is why order of operations is important, because what we cannot do is we cannot just pick and choose what we want to solve first. Order is going to matter. All right, so we'll come back to Emily and Tracy here in just a second, and let's talk about what the order of operations actually is. So the way that we should, and the correct order in which we should work out problems goes like this. The first thing that we should always deal with is groups. Now, some of you may have started this acronym out with a P in the beginning, in maybe in 5th grade. So I'm going to write that off here to the side. P always stood for parentheses, that you should use parentheses first. I like using G because it stands for grouping. Grouping symbols, which can include parentheses, but also can include like these brackets or even like a fraction bar. So there's lots of different grouping symbols. So I like to use G for grouping. If you like P for that first line for parentheses, that's also fine. Just keep in mind that there's lots of different ways parentheses could look. All right, E comes next. And again, you probably learned it PEMDAS. I'll just go ahead and write that over here. So the E was next, and then MDAS. So if you learned PEMDAS, or maybe please excuse my dear Aunt Sally, that's what we're talking about here is order of operations. So the E comes next, and it stands for exponents, which we already have worked on this year, which are those little numbers that are floating up in the air, which tell you how many times to multiply something. All right, now on the next line, we're actually going to write the M and the D next to each other, because M and D stands for, and I'm just going to write the symbols if that's okay with you all, multiply and divide. But multiplication and division come together. We do them in the same step, but they come from left to right. So it's just the way that we read. Whenever you come to multiplication and division problems, you're going to do whichever one comes first. Left to right, whichever one comes first. So if you have multiplication and division, the first line, you actually could do division before multiplication. Same thing with addition and subtraction. So the A and the S in the end stand for addition and subtraction, and we're also going to do them left to right. Okay, so I like calling order of operations GEMDAS. Maybe you draw a big box around this or something. You could also, of course, use PEMDAS. If the P makes you feel better in the beginning for parentheses. So PEMDAS or GEMDAS is what we are using to help us remember the correct order in which to work out problems. And so we're going to start with actually a very large problem. And we're probably going to have to use the back of this page to put some more examples in. But we're going to start with a very large problem just so we can work through this step at a time, okay? So our problem is going to be, and maybe start it up here next to your problem so you'll have enough room to go down. So 17, right, pretty small, minus 5 squared divided by parenthesis 2 plus 3 plus 1 times 2. All right, I'll give you a second to write that down. All right, and so we've got a lot of operations here, right? Like if you just look at this math problem, number one, it looks really long, looks really big, and I also noticed that I've got subtraction, I've got exponents, I've got division, I've got addition, I've got another addition, and I've got multiplication. Like basically I have every operation that I possibly could have, including these numbers in parentheses here. So I'm going to start at the beginning, and I'm going to do in the correct order the problem that what we are not going to do is kind of what Emily did up here. We're not going to just start at the beginning and hope for the best. We have to do them in the correct order. So the first thing that we're always going to do is G for grouping. So I look through my problem, I ask myself, do I have any grouping symbols? And I do, and I'm going to underline them. I'm going to underline that group, and I'm going to work out what's inside that group first. So, and if it helps, I always like to, we've got the order of operations written over here, but I would suggest every time you work one of these to maybe write GEMDOS or PEMDOS, if you like the P better, over here off to the side, and that way you can mark them off as you go. So G stands for grouping. I do have grouping. I'm going to work this problem out first. It's in parentheses. 2 plus 3 is 5, and I'm going to write 5 right below that, and then I'm going to bring everything else straight down. Everything that I have not used already, I'm going to bring it straight down. So now I have my grouping symbol worked out, but I still have everything else to do. Now, are there any more grouping symbols? Are there any more parentheses or brackets or fraction bars? And again, this, would be like a number up here, or something up here and something down there. So I don't see any of those things. So my grouping is done. I'm finished with my grouping, and so I'm just going to mark it out. All right, the next thing we come to is E, which stands for exponents. So I look through the problem. Do I have any exponents? Yes, I do. And so I'm going to underline my exponent, and I'm going to work that out. 5 squared, remember, is not 5 times 2, but this is 5 times 5. It's the base number, remember, multiplied by itself this many times. So I write the base this many times, 2 times. 5 times 5 gives me 25, so that's going to be the answer to that problem. And then I'm going to bring everything else straight down. And you can scoot things a little closer together as you go if you'd like. All right, so I've worked the exponent out, and then I look through the problem. Do I have any more exponents? Do I have any more numbers floating up in the air? I do not, so I mark out my exponent. Now M and D come together. Multiplication and division are going to come in the same step. And so I look, and I ask myself at the same time, is there multiplication or division? Well, yeah, there's division and there's multiplication, and I want to do the one that comes first. So reading left to right, even though M is written first here, that doesn't mean you have to multiply first. It means we do these together. And so if I'm looking left to right, I notice that I come to my division problem first. And so I'm going to work it out first. 25 divided by 5 gives me 5. So I find the answer to that problem. And then again, I'm going to bring everything else down. So 17 minus 5, and we've still got plus 1 times 2. Okay, are we done with multiplication and division? Not yet. We still have a multiplication problem that, again, I'm doing left to right. And so the multiplication problem is all that's left. 1 times 2 does give me 2. So write your answer down below it and bring everything else down. Make sure you don't lose anything along the way. So now I look at my problem. Do I have any more multiplication and division left? I do not, so I can mark that out. So the last thing to do, the last thing that you're always going to do in order is addition and subtraction. And again, this is going to come from left to right. I'm going to do it in the order in which I see it because they come together. Addition and subtraction, left to right. So I look for additions, and that's all I have left, right? I have a subtraction problem and addition problem. The subtraction problem comes first, so 17 minus 5. I subtract those numbers, and 17 minus 5 gives me 12. And I'm going to bring down the final plus 2, and then that's the last problem that I have to work. The addition problem, 12 plus 2, gives me 14. And so my final answer to this problem is 14. You're always going to end up with one final number. Some people have even said that this sort of looks like a slice of pizza because it should get smaller as it goes down. This is kind of a wonky pizza, but it's got a pepperoni at the end always. So as you're working out this problem, it should be getting smaller and smaller until you get one final answer at the end. And so the answer here is going to be 14. And so that's what we want to make sure that we're doing it in this order, always using the order GEMDOS in which it is written. And that does mean we're going to work out some problems in the middle of the problem first, right? We're not just going left to right. We're going in order of the order that has been decided for us that all math problems are going to be worked out. All right. So we're going to do a couple more. We're going to throw some negative numbers in here. Actually, on this page, let's look at, let's see, what should we do here? we're going to do 6 examples, okay? So go ahead and you can split your page on the back. You can split your page down the middle. And then, well, just split it down the middle and we'll alternate between the sides, okay? So let's do example. We're going to do 6 examples, and I'll let you try a couple on your own. So example number 1, let's do the problem. 3 times -4 divided by 4 times -1. All right, so go ahead and copy that down. And again, we are always going to be using order of operations. And so I would suggest when you copy a problem down, you see a problem on your screen, and you're like, okay, I need to solve that problem. Then copy it down. That way you'll have enough room to work it out. And beside of it, go ahead and write GMDOS or PEMDOS if you like the P better for parenthesis again. But it's always going to be in this order. GMDOS. If you remember it with the P, it's please excuse my dear Aunt Sally. GMDOS is just the way that I remember, just by remembering that acronym. GMDAS. All right, so we're going to work through the correct order. We first look and ask ourselves, are there any group? G stands for grouping. So I look for grouping symbols. I do see some parentheses. So I'm going to underline that set of parentheses first. I'm going to work out that problem. 4 times -1. Well, 4 times 1 gives me 4. But I know from my last unit that a positive number times a negative number is a negative number. And so my answer to this problem inside the parentheses is -4. Once you work out everything inside the parentheses, you don't have to bring down, once you've solved the problem, the parentheses are gone. So I'm going to bring down everything else that I have not already used. And then I look and I ask myself, are there any more grouping symbols? Well, no, the parentheses are all gone. There's no other brackets or fraction bars. And so my grouping symbols are finished. So I get to mark it out. Now, are there any exponents in this problem? Well, no, I don't see any numbers flying up in the air. So I don't even have to do that step. The exponents are not existent. So the E is gone. Is there multiplication and division? There is. And that's all we have left, right? We don't even have any addition and subtraction. We've got multiplication and division only. There's a multiplication problem here, division problem here. We're going to do them left to right. So it does not matter what order they're in, but it's which problem comes first, because multiplication and division are done together. And this is going to be 3 times -4. So 3 times 4 is 12. A positive times a negative number does give me negative. And so the answer is going to be -12 divided by -4. Okay, I can't mark this out yet because I still have division to work out. And actually, it's the last thing to actually work out. So 12 divided by 4. 4 goes into 12 3 times. And we have the same sign here. So a negative divided by a negative, again, remember from last unit, is a positive. So 12 divided by 4 is 3. Negative divided by negative is positive. And then we circle our final answer. We are done with multiplication and division. There was no addition and subtraction. And so order of operations is complete. And we have ended up with our final answer of 3. All right, let's do one with an exponent in it, and let's do one where we've got a couple more steps that we actually might have to complete. So let's try one that looks like this. Example number 2. All right, so we're going to write down 4 divided by 2 times parenthesis 10 minus 5 plus 2 squared. All right, so let's work on this one. So there's a couple of things here. You're going to copy down the problem first, and then always, always, always we're going to write down GMDOS next to it so we can keep up with what step we're on, what order we're doing this in, okay? So G, of course, stands for grouping, and I notice that I do have grouping symbols, but notice there's a lot of stuff inside here, right? So there's a lot of things going on inside my group. I still want to make sure I work out my group first, but within the group, I want to make sure I'm using order of operations. So I'm going to look inside the group here, and notice inside the group I've got subtraction and addition. And so which one comes first? Well, overall in order of operations, addition and subtraction come together, but remember we do those from left to right. So inside the group, when you have multiple things inside the group, you also want to follow order of operations. And I know that addition and subtraction come together left to right. So I'm going to work out my subtraction problem first, because you can do subtraction before addition. And so I'm going to work out this piece first. 10 minus 5 does give me 5. And I'm going to very carefully copy down everything else that I see. Now this is a point at which you cannot get lazy on me. You cannot do these in your head because you will miss something. Make sure you're writing this work down. If you miss problems because you're not writing them down, don't send me a message and say, I don't know why I'm missing them. Make sure you're writing this stuff down. It's important to keep up with the order. All right, now, notice I've not worked out everything inside my parentheses, right? And so I still have some work to do inside parentheses. And so inside the group, 5 plus 2 is the last thing I need to work out. 5 plus 2 is 7. Now, everything inside the parentheses are done, but notice I still have this exponent on the outside. Once you work out everything inside parentheses, you don't have to copy the parentheses down, but I do need to bring down that square. So I'm done with groups, and I'm going to bring everything else down. All right. So now I'm done with my group. No more parentheses left. I move on to exponents. I do have an exponent, and that's 7 squared. That's not 7 times 2. Don't put 14. This is the problem. Remember, 7 times 7. Write your base this many times. 7 times 7 is 49. And I bring everything else down. All right, exponents are gone. I'm ready to multiply and divide left to right. And that's actually all I have left. I don't have any addition, subtraction here. Multiplication, division, left to right. This problem, division problem, comes first. 4 divided by 2 gives me 2 times 49. And I've still got one more multiplication problem, last problem to work out. 49 times 2, if you don't know what that is, you'll have to come off here to the side and work it out. 9 times 2 gives me 18. Carry the 1. 4 times 2 gives me 8, plus 1 is 9. So 98 is your final answer for example number 2. So notice it's the same problem over and over again. Or it's the same type of situation over and over again. We're finished with this. We're using the same order. It's just important that you not only work out the problem correctly mathematically, but that you're also following the correct order. All right. I'm going to write one down for you to try. So let's try example number 3. Oops. I guess it would help if I actually wrote example number 3. And for example number 3, I'm going to write out the problem, and then I want you to take a second, maybe pause the video, try it yourself, and then we'll check the answer. So let's see what this looks like. So 2 plus 3 multiplied by 21 divided by 3. So go ahead and take a second, see if you can work that out on your own, see what you get, and then we'll come back and make sure you did it correctly according to order of operations. All right, so I hope you took a second. I hope you paused the video and worked this out, trying it on your own. Now we look for grouping symbols, and of course we have 2 sets of grouping symbols here, right? Now you could work them out in the same step. You could underline both of these and just get the answer. I'm going to do them one at a time. So the first group that I come to is 2 plus 3. I get the answer 5, and my parentheses are gone. Times, and then if I brought everything else down, I still have this 21 divided by 3, which is still a group, and so I'm going to work it out as well. 21 divided by 3 gives me 7 times 5. I have no exponents to work out, but there is a multiplication problem. Of course, it's the last multiplication problem to work out. 5 times 7 gives you 35. There is no addition and subtraction, and so your final answer comes out to be 35. All right, let's do one more. I said we were going to do 6. We might only do 5. But let's look at another one with some negative and positive numbers in it, just to make sure that we're okay with those. So let's try 3 times negative 5 plus 7 minus, and then in parentheses, negative 1 times 4. Yeah, let's do that. All right, And so again, we're just going to write down GMDAS. Kind of meant to put a exponent in there somewhere. We'll do another one with an exponent here in a second. All right. So we're again just following the order of operations. This should get very familiar, right? Because we're looking for the same stuff all at the same time, in the same order. So G stands for groups. I look through. Do I have a group? Absolutely. Negative 1 times 4. Well, 1 times 4 is 4. A negative times a positive gives me a negative. So my answer here is negative 4. Bring down everything else that you see. Are there any more groups? There are not. I'm ready to move on. Are there any exponents? No, I meant to write one into this problem and I didn't. So no exponents. Multiplication and division come left to right. There's only one multiplication problem that I see here, and it's 3 times negative 5. 3 times 5 is 15, but a positive times a negative gives me a negative answer. So negative 15 plus 7 minus negative 4. There's no more multiplication and division, so I get to mark it out, and I'm ready to add and subtract. Addition and subtraction come together left to right, so I'm just going to start at the beginning, and I'm going to move my way over. So negative 15 plus 7. So we have to think about our rules for adding integers. Negative 15 and this is positive 7, so 2 different signs. I'm going to come over here to the side and actually subtract them because they're different signs. 15 take away 7, you have to borrow, which gives you just 15 minus 7, which is just 8. And then we look and say which one had more. Well, there were more negatives than positives, so negative 8. And then minus negative 4. The only problem left is negative 8 minus negative 4. We have to remember our subtraction rules now. Every subtraction problem that you see with negative numbers in it has to change to an addition problem. So we're going to keep, switch, flip. We're going to keep the negative 8. We're going to switch the subtraction to addition. And we're going to flip the sign of the last number. It was negative 4, now it's going to be positive 4. We're adding now 2 different signs, which is exactly like what we were doing up here, so we actually have to subtract them. 8 minus 4 gives me 4. And which one had more? There were more negatives, so the answer is negative 4. So you might actually end up with negative numbers, especially if you have negative numbers that you're dealing with in your problem. All right, one last problem that we want to make sure that we work out together, and that's going to be one where we actually end up with a fraction bar. Yeah, we're just going to call it a fraction bar. All right, so example number 5, this will be the last one that we do together. We're going to do, let me find a good one here. All right, let's do this one. 27 divided by, in parentheses, 3 times negative 3, and then over, all in a fraction bar, over 5 minus 4 plus 2. All right. So again, we're using order of operations. And if you'll remember, back in the very beginning, we said that a grouping symbol could also include a fraction bar. A grouping symbol as a fraction bar means, here's what it means. It means that the top is a group and the bottom is a group. And so if you see a problem that has a fraction bar in the middle of it, what we have to do is we have to treat the top like it's a group and the bottom like it's a group, and we're going to have to work those out first. So if you see one with fraction bar, here's what we're going to do. I'm going to just label it. Here's the top. The top is 27. I'm going to rewrite it. Divided by 3 times negative 3. That is what I have on the top. On the bottom, which I'm going to label B, I have the problem 5 minus 4 plus 2. Maybe we will do example 6, and I'll give you one of these to work out on your own. All right, so I'm going to work them as separate problems. I'm going to work out the top as a group. I'm going to work out the bottom as a group, and then I'll show you what to do. So we're going to look at the top problem first. We have 27 divided by, in parentheses, 3 times negative 3, I'm sorry. So there is a group. We're going to underline that. We're going to work that out. 3 times 3 gives me 9, but a positive times a negative gives me negative, so that's negative 9. And so 27 divided by negative 9 gives me, 27 divided by 9 is 3, but a positive divided by negative gives me a negative. So the answer to the top up here is negative 3. So what I'm going to do is I'm going to come back up here where the problem is, and I'm going to write down negative 3. Now, it's over something, so now I'm going to work out the bottom. So 5 minus 4 plus 2 is on the bottom, and I'm going to follow order of operations. So there's no groups, there's no exponents. There is, though, multiplication and division. Oh, no, there's not multiplication and division. I'm sorry. The only thing we have is addition and subtraction, which come together left to right. So I'm going to do the subtraction first. 5 minus 4 gives me 1, plus 2. 1 plus 2 gives me 3. And so on the bottom, we end up with the number 3. So we work out the top and the bottom first. And so what I end up with is this, negative 3 over 3, which is just a division problem. And so what is? Well, 3 divided by 3 is 1. A negative divided by a positive is negative 1. And so that's how we get our final answer, is that in the end, we divide. All right, so last one, I'll just have you try one on your own if you want to pause the video after I write this down. Let's see what you can do with this one. So let me find a good one. I want to do one with an exponent in it. Do I have one? Do I have a problem written down with an exponent in it? Not really, but I can make one up. All right, so let's do this. On the top, we've got 2 times 10 divided by 4 in parentheses plus 5. And then all over 5 squared minus 20. All right, so remember again, write it out. Okay, what's on the top? I've got 2 times 10 divided by 4 plus 5, all in parentheses. And on the bottom, I've got 5 squared minus 20. So go ahead and pause the video, work out the top, work out the bottom, see what you get, put them over top of each other, and then divide. Go ahead and pause the video and try that. All right, so I hope you paused the video. We're just going to check this very quickly. Again, we've got order of operations to get through, so G, E, M, D, A, S. You should get really tired of writing that out. We're going to work on the top first. Grouping symbols. Yes, I've got multiple things happening inside this grouping symbol. There's multiplication and division. Multiplication and division come together left to right. So I'm going to start with the multiplication. 2 times 10 is 20. I still have parentheses because I've still got stuff in there, plus 5. Still got a group, so I'm going to finish working it out. 20 divided by 4 is 5. And 5 plus 5, addition and subtraction, gives me 10. So my top number for the top is 10. On the bottom, I've got exponent, and then I've got subtraction. So there's no grouping, but there is exponent. I'm going to do it first. 5 squared is not 5, or 5 to the second power is not 5 times 2. It's not 10, but it's 5 times 5, which is 25 minus 20. And then my subtraction problem, 25 minus 20 is 5. Now that's the bottom number, right? That's what we get when we get the bottom. So our final is 10 over 5, using the answer from the top and the bottom, and 10 divided by 5 is 2. All right. So that is order of operations. Every time you work one of these problems, you need a piece of paper, you need to write out the problem, you need to follow these steps and mark them out as you go. Do grouping first, exponents, multiplication, division left to right, addition, subtraction left to right, and you are good to go. Make sure you message me if you have any questions about order of operations.